G'day team, welcome to week 19 of Statistics 1 Maintenance, where we go over some of the topics that we've already covered and just to maintain our skills across the curriculum. So the first question, as per usual, is the representation of data question. This is from a past exam question where we have a back-to-back stem and leaf diagram showing the times to load an application on 61 smartphones of type A and 43 smartphones of type B. The first thing that we have to do, there's a key here which helps you understand what the bit in the middle means. So this here means 0.23 for type A and 0.21 for type B. So we're going to find median and quartile for each smart phone. So 61 of type A. So the middle value is going to be the 31st item of data, because if you go 61 divided by 2 you get 30.5, so you round up. So the 31st item of data. So what we can do is we can just work our way down here. 7 plus 7 is 14. 27, and then that will be 36. So it's going to be in there. So we're going to go, we'll start from 27 here, and then we're going to go 28, 29, 30, 31. So I think this one here is our median. So median for the type A smartphone is 0.52 seconds. And then we're talking about the lower quartile. So to find the lower quartile, you just go 0.25 times 61, and we're looking at the 16th item of data. Or another way of doing it, actually, you can see that we've got 30 items of data below 0.52. So from here downwards, right? All of this is 30. So we're going to find the 15th and 16th and divide them by 2. So that's what I'm going to actually do. 15th and 16th. So 17, 14, right? 14 down to here, and then 15 and 16. So these are our two middle numbers here. So our lower quartile should be halfway between them, which is 0.41. And now we'll look at our upper quartile. We want, again, these 30 items of data on the top half. So we want to find item 15 and 16 and find midway between them. So we start here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So this is 15 and 16 would be this one here. So halfway between them will be our upper quartile. And in this case, our upper quartile is 0.79. So there we go. That's fairly easy, 0.79. Now, what are we doing next? You're given that the median and lower quartile smartphones be 40. Okay, right. So we're given some other data here, and we've got to draw in these boxes here. Okay, so the trick here is I'm going to have to try and make this small enough so I can see all of the data at the same time, which is going to make it that much more tricky to draw. We'll see how we go. So our lowest value, I think I could probably just go, let's go up in 0.1. So this will be 0.2 here. We've got a 0.4 here, 0.6 here, 0.8 here. No, let's put a point in there. And this is a 1.0 here. Yep. And we'll start off with A. So the lowest value of A is 23. So let's do, this is A, 0.23. So 0.23 would be approximately, I guess about there. And the highest value for A is in 0.98. So we're all the way over to here. Okay, and we've got a lower we've got a median at 0.52, so 0.52 would be here, and then we've got a lower quartile at 0.41, which is sort of there, and we've got an upper quartile at 0.79, which of course is there. Okay, so those are those values. Now I might just go in so I can see this a bit better. So I guess I can draw a line like that, and I'll have a box that goes all the way, and of course you're going to do this with a ruler. I'm drawing it on the computer and I am not very competent at that. And then I've got this median in here, and then the whisker parts go out to our top value and our lowest value here. Now we're going to do the same for the type B. So for type B, our lowest is 0.21. So we'll do type B a different color. 2B, 0.21. So starting a little bit further back, so like here. And then we've got our highest value is 0.96, so it doesn't quite get as high. It's 0.96 there. And then maybe we'll make a different color so we can see a bit better. And then we've got our other data, which is 0.46 for our lower quartile, 246. So I think that's there. Then we've got a sorry, that's median. The lower quartile is 0.36, so that's back to here, lower quartile. We've got a 0.63 for our upper quartile. So I'm going to scroll back in so I can see this a bit better. And again, you're going to use a ruler. I can't. So we go there, we go up here, down there, along this box bit. Join it up with that bit, which goes to there. Join it up with this bit. There we go. So blue is type B, and then we've got the pink one is A. Compare the loading times. Well, what can we say about this? I guess we can say A takes longer to load. The A cell phones take longer to load, and you can see they're more variable and are more variable in their times and loading times, and you can see that because of the size of the box. Okay, well, there we go. Moving on, Jody tosses a biased coin and throws 2 fair tetrahedral dice. Probably the coin shows a head. Oh, it's biased, right? Okay, yep. There's a third, and each dice has 4 faces. Okay, cool. Jody's score is calculated from the number on the faces that the dice lands on as follows. So if the coin shows head, then the 2 numbers are added. And if the coin shows a tail, the 2 numbers are multiplied. Okay. So what we're going to do here is we want to find the probability that that she's going to get an 8. So the way she could do this is if she gets a head, and then she gets a 4 and a 4. Okay, that's the only way she can do it, with getting a head, because we're adding. Okay, and 4 and 4 is the only way to making 8. So to think about the probability of this, we already know that the probability of this is a third. I think we get a third for heads times 1/4 squared, right? 1/4 squared. Now, the other way we could do it is if we get, let's say we get a tails, and then we're multiplying them together. Now, what's the way that we can multiply to get 8? Well, we could get 2, 4, or alternatively, we could get 4, 2. So the way we describe this is it's got a 2/3 chance of getting the tails, and then we've got a 1/4 squared chance, but we've got 2 ways of doing that. So we could have it 2 and 4 or 4 and 2. So there we go. Now we are trying to find the probability of head given score is 8. Given that we have an 8, okay? Well, this is equal to the probability of head intersection 8 over the probability of 8, getting an 8, okay? So, probability of head and 8 is this first bit, which is 1/3 times 1/4 squared, and then over the total probability of getting 8, which is, these are the only ways of getting 8, so 1/3 times 1/4 squared plus 2/3 times 1/4 squared times 2. Now, when I did this earlier, I got 1/5. Hopefully that's right. When I add that all up. Okie dokie, moving right along. So we've got a discrete random variables here. First of all, we've got to find the value of k. So, in essence, what we're trying to do is find all of these should add to 1. So we're going to go 1, take away 0.24 plus 0.35 plus, there's 3 k's altogether, plus 0.05, and that should be equal to 0. Okay, and we can solve it. So 3k, and when I do that, I should have put the 3k across the other side. So 3k equals 9/25, and so therefore k is equal to 3/25. Okay, now find the mode. The mode of x is therefore going to be what is that? 1, I think. 1, because 6 over 25 is the same as 0.24, so 0.35 is bigger, so mode is 1. Find the probability that the number of phone calls received by Sarah on any particular day is more than the mean number of phone calls. Okay, so first of all we want to find the mean, and we do that by finding EX, or expected value. So it's 0 times 0.24 plus 1 times 0.35 plus 2 times 2k, which is 6/25, plus 3 times now k, which is 3/25, plus 4 times 0.05. Now when we pop that into the old calculator, I'm getting 1.39. Now, the question is asking, find the probability that the number of phone calls is more than the mean number of phone calls. Okay, so 1.39. So the probability that it's more than that is going to be these bits here, like you get 2, 3, 4 or more phone calls. So it's simply going to be 0.2 greater than 4, which is the 2k, plus 0.12, which is the k, plus 0.05. And this gives us a total of 0.41. That's the probability. Now moving on to our favourite, permutations and combinations. Let's see how wrong we can go with this one. Positive, of course. Committee of 6 people is to be chosen from 5 men and 8 women. And how many ways can this be done if there are more women than men on the committee? Okay, so if there's going to be more women than men, you either have to have, say we've got women, men to men, have 4, 2, that's one way we could do it. Or we could have 5, 1, or we could have 6, 0. Okay, now let's consider this first option, 4 women. Now to get that, we would do, out of the 8 women, we're going to choose 4, so there's 8 choose 4 ways we can do that, and then we've got to choose 2 men out of the 5, so 5 choose 2. And then this way here, we're going to choose, out of the 8 women, we choose 5, and then out of the 5 men, we choose 1, so that's times 5, or 5 choose 1. And then lastly, all 6, we're going to choose 6 women, so it'll be 8 choose 6, and then 5 choose 0, which is just 1, isn't it? This is just 1. Okay, now what we do here is we sum all of those together. And when I sum them together, and probably if I was doing this in the exam, I'd write each one out, what it's worth. But I'm not going to do that for now. I'm just going to write the total of this is 1008. Now, what happens if the committee consists of 3 men and 3 women, but 2 particular men refuse to be on the committee together? Okay, so what I do in this case is I'm going to think of Grumpy Man 1, Grumpy Man 2, and then we have the good, wait a second, yeah, the other men, so there's 3 other men, the good men, and then the 8 women who aren't grumpy. Now, so how can we pick these? Well, let's have a think about this. This is a bit tricky, isn't it? Okay, let's say first of all we go, let's pick man 1. So if we've got him, and then we'd have to pick out of the men, 3 choose 2, because we need 3 men altogether, and then out of the women we've got to choose 8 choose 3. So that's one way of doing it. Now, of course, we might instead select this grumpy man, and then we'd have to choose another 2 guys, so that would be 3 choose 2, times out of the women we're going to choose 8 choose 3. Okay, and then the other thing is we could just completely ignore those dudes and select just from this group, so we don't have any of the grumpy men on. So we would go 3 choose 3, so that's 1, and then times 8 choose 3. Now, another way of writing this, so I guess we can look at this bit here, right, this black box one here. So this is like 2 lots of 3 choose 2 times 8 choose 3, and then we just add on plus 8 choose 3, which is the scenario where we don't choose any of the grumpy men. Now, you might be thinking, why do you leave off 3 choose 3? Well, because 3 choose 3 is just 1. It's one way of doing it. Okay, so when we chuck that all together, I don't know, what did we actually even get? Okay, when I did this earlier, I got 392 ways of doing it. I hope that's right. Okay, next one. One particular committee consists of 5 women and 1 man. What? I think that's meant to be how, right? How many different ways can the committee members be arranged in a line if the man is not at either end? Goodness knows why this committee is particularly interested in this problem, but okay, we'll do it. So we have to have woman here, 1, 2, 3, 4, and woman here, okay? And the man's not allowed in any of those positions. Who knows why? Because math, okay? So, well, I guess the man has 4 different ways, 4 different places he can be, right? And the way we can arrange the women, because we've got 5 women, we can arrange the women in 5 factorial ways. And then for each of those ways, the man has to fit in 4 different places, right? Could be here, 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 or here, right? So you've got 5 women, 5 women, 1, 2, 3, 4, 5, right? And the man has 4 options for where he goes for each of the ways you arrange them, right? The 4 options are he could slip in here, there, there, or there. Not here, not here. So that's why I'm doing 5 factorial. That bit there is referring to how we arrange the women, and then this bit here, for every arrangement of the women, there's 4 places that the man can go. Alright, we're on the last one. We're doing really well. Okay, so in a certain mountainous region in winter, the probability of more than 20 centimetres of snow falling on any particular day is 0.21. Okay. Find the probability that in any 7-day period of winter, fewer than 5 days have more than 20 centimetres of snow falling. Okay. The way I would do this is I would find the chance of 6 and 7, 5, 6 and 7, and then I would subtract it from 1. So I'm going to go 1, and then I'm going to take away the probability that we have 5 days, so that would be 7, choose 5. Now this is binomial, so what is the probability of a one day being having snow more than 20 centimeters of snow falling is 0.21, and since we're doing 5 days, it'd be times to the power of 5, and then the other days, the chance of no snow is 0.79, and we've got 2 of those days. Then we've got to think of the situation where we have 6 days, so that would be 7, choose 6, and we'll have 6 days of success, or 6 days of greater than 20 centimeters snow, and therefore we'll only have 1 day of less than that. And then finally we would have all 7 days having that much snow, so we're going to have 0.21 to the power of 7, and then our failures to have that would be to the power of 0, because there are no days that have that. Now when I chuck this into my calculator, I got 0.994. Okie dokie. Now the last one, for 4 randomly chosen 7-day periods in winter, find the probability that exactly 3 of those periods will have at least 1 day with more than 20 centimeters of snow falling. Okay, so let's first of all find the probability at least 1 day of 20 centimeters of snow falling. So 1 day, to find that we go 1, take away the chance of 0 days having more than 20 centimeters snow falling. So that would be take away 7, choose 0, so 0 days, 0 successful days of snow, which means that the 7 days would all have less than 20 centimeters of snow. So we take that away, and that will give us, there's a 0.808 chance that we have at least 1 day of snow falling, because we've got rid of, so this bit here is no days with greater than 20 centimeters. Okay, now that's for 1 week. What we want is the probability that exactly 3 of the 4 randomly chosen periods. Okay, now that will be, we've got 4 randomly chosen periods, but we're selecting 3 of them. So 4 choose 3, and we want 3 of them to have at least 1 day, with more than 20 centimeters of snow falling. So we want the probability of that being successful, which is 0.808 to the power of 3, and then obviously times the probability now of one of those weeks not having more than 20 centimeters of snow. So this one is 0.192, and the way I get that is I go 1 take away 0.808, and that's to the power of 1. So this bit here represents the 3 weeks where we have at least 1 day with greater than 20 centimeters snow, and this bit here 1 week where there are no days of greater than 20 centimeters of snow. Okay, now when we chuck that into the old calculator, I got 0.405, so I hope that's what you got as well. Alright team, well that'll do for today. I hope the maintenance is proven to be helpful for you. I hope it's preparing you well for the exam that's coming up, looming in fact. So let me know if you have any questions. Alright team, God bless.